So take a look at this algorithm here, and we see that it starts with just this binomial. We have some number times x plus some number, another number times x plus some number. And when we expand this, we're going to end up getting acx squared plus adx plus bcx plus bd. So you'll notice that we have all four of these numbers represented here, a, c, b, d. So we can say that if we multiply this coefficient by this constant, we're going to get a, b, c, d. You can also see that here, these two terms are both coefficients for x, which means that our x coefficient is actually going to be AD plus BC. And so what we can say is that our x coefficient is going to be AD plus BC, which means that if we can find the numbers AD and BC that add up to our x term coefficient, and that multiply to our product of the first and last numbers, then we have found a way to factor our quadratic. Okay, so in this case, when we multiply out 2x plus 5 times 3x minus 2, we end up with 6x squared plus 15x minus 4x minus 10. So here we have, so this is A, B, C, D. And so what we can see here is that here, this is equal to BD here. This 6 is equal to A times C. The 15 is equal to BC. And the negative 4 is equal to AD. So we know that we can also say that A times B times C times D is equal to A times AC times BD, or 6 times negative 10. We also know that BC plus AD is equal to positive 11. And so if we were just to write out this with simplified form, we would get 6x squared plus 11x minus 10. We know that that can be factored. The question is, how do I get from here to the factorization? So the first step is we multiply the 6 times the negative 10, which gives us negative 60. And then we find two numbers that multiply to negative 60, but add up to positive 11. And that we already know from what we've done would be 15, negative 4. Okay, so in order to use this for factoring, here's what we would do. We would say, once we have our two numbers, 15 and negative 4, which multiply to negative 60 and add to 11, we would be able to take, let's say we had just started with 6x squared plus 11x minus 10, and we found our 15, we found our negative 4, we could then rewrite this as 6x squared plus 15x minus 4x minus 10. Now notice the value hasn't changed because these still add up to 11x. Now we take out the common factor from these first two terms, which is 3 out of the 6 and the 15, and then x. That leaves us 2x plus 5. Then we take our common factor out of the negative 4x, negative 10, that would be negative 2, which leaves us with 2x plus 5. Now, if we're doing this correctly and this is factorable, this is what's going to happen. We're going to have two of these same values in parentheses. Okay, so now this can be factored to. We're going to take our 2x plus 5 out, and that leaves us a 3x and a minus 2. Okay, so this is our factorization. Now we already knew what it was going to end up as because we saw that that's how we started. But let's take a look at some other examples here. Okay, so we have 6x squared plus 7x minus 3. So we multiply our 6 times our negative 3, we end up with negative 18. we know that our BC plus AD equals 7. So what we want to do is we want to find the two values that sum to 7, multiply to negative 18. And so those could be negative or positive 9 and negative 2. And so now what we can do is we can rewrite our quadratic expression so that it is now 6x squared, and instead of 7x, we're going to have plus 9x minus 2x, and then we still have our negative 3 as our constant, so we have this. The reason we do this is because we can now take common factors out of both of these terms. So here we're going to get 3x times 2x plus 3. Now notice we have a negative 2x minus 3, which means that if we take out a negative 1, we're going to have another 2x plus 3. And what that means is that we factor out the 2x plus 3, and what we're left with is 3x minus 1. And that's the factorization. Okay. So then we did another example here, and we looked at how we can do the same thing with 15x squared minus x minus 6. We multiplied the 15 by the negative 6 to get negative 90. Then we needed to find, since the coefficient of the negative of the x term is negative 1, we need two numbers that multiply to 90, add to negative 1, and those would be negative 10 and 9. So then we can break the middle term into negative 10x and 9x. Notice that we can actually do it in either order. It's not going to matter in the end. So if we do it the first way, we would say we would factor out a 5x, and that would leave us 3x minus 2 from these first two terms. And then we factor 3 out from 9x minus 6. That leaves us a 3x minus 2 again. And so that would leave us then down to here, where we would say we'd factor out the 3x minus 2, leaving us with 5x plus 3. Over here, when we factored out the greatest common factor from 15x squared to 9x, we factored out a 3x, leaving 5x plus 3. Then we factored out a negative 2 from negative 10x minus 6, leaving another 5x plus 3. And that we can then sort of factor that out to get 5x plus 3 times what's left over, which would be 3x minus 2. So again, both ways we get the same. And you'll notice that, of course, when we multiply this back out, we had certainly better get back to our original 15x squared minus 9x minus 10x plus 6 gives us 15x squared minus x. 5x plus 3. And so this will be a plus 9x. And this will be a minus 6, so we get this. Okay, let's do it with this one. All right, first thing, 6 times 2 is equal to 12. And by the way, this should be a negative 7, otherwise it doesn't work. And then we need two numbers that multiply to 12 and add up to negative 7. So those two numbers would be negative 4 and negative 3. So we'll say 6x squared minus 4x minus 3x plus 2. Now, again, negative 4x plus negative 3x is equal to negative 7x, so we didn't change the value. Okay, we'll now factor out 2x from here, leaving us 3x minus 2. And then we'll factor out a negative 1 here, leaving us 3x minus 2. And that gives us 3x minus 2 times whatever's left over, the 2x and the negative 1. Okay, so that would be the factorization of that. And then if we want to factor the next one, we would say, all right, we have 10 times negative 12 is equal to negative 120. We want two numbers that multiply to negative 120 and add up to negative 7. Okay, those two numbers would be negative 15 and 8. So we would say 10x squared minus 15x plus 8x minus 12. And when we factor, we take out a 5x times 2x minus 3 plus, and then we'll factor out a 4 here, 2x minus 3, yielding in the end 5x plus 4 times 2x minus 3. Okay, let's continue. Okay, so you should review these general forms for factoring a perfect square trinomial, a plus b squared, and the difference of perfect squares, a squared minus b squared. Okay, is this first one certainly not a difference of perfect squares? Is it a perfect square trinomial? Can it be factored into the form a plus b squared, which would be a squared plus 2ab plus b squared? So that means that a squared is equal to 49x. Okay, that works. So we get, that's a perfect square, so we get a is equal to 7x. B then would be equal to y. And so the middle term, whoops, that's, sorry, there should be a y there. The middle term then would be 2 times 7x times y equals 14xy. And that works. So this can then be factored to 7x minus y squared. Okay. Sorry about that error there. All right, the next one, the first thing is, and this will always be the first thing when you're factoring, is look for any common factors. Well, we can factor 3x out of this, leaving us x squared minus 9x. I'm sorry, minus 9. And that's the difference of perfect squares, so we end up with 3x times x minus 3 times x plus 3. Okay, this next one, difference of perfect squares, a squared minus b squared. So that's going to factor to a minus b times a plus b, where a is equal to 3x minus 1, b is equal to 2x minus 1. So a minus b is going to be 3x minus 1 minus 2x minus 1. A plus b is going to be 3x minus 1 plus 2x minus 1. This is going to simplify to the 3x minus the 2x will leave us x. The minus 1 minus the negative 1 will cancel out, so we'll just end up with x here times 5x, and then minus 1 minus 2. And that, as we keep expanding, would be 5x squared minus 2x. Notice that's going to be a whole lot easier than expanding those, multiplying them out, and doing all the simplification. It's recognizing that we're working with a pattern here. Okay, these I'll do in a separate video.